Hello everyone, welcome to another video. Today I'm showcasing an incredible project built by one of our YouTube members, Suraj. He designed and deployed a complete production grade event ticketing platform on AWS EKS using Terraform, ArgoCD, GitHub Actions, Prometheus, Grafana, Loki, Kyverno, Cosign, Velero, RDS, Redis, and there's much more. What makes this project stand out is that it doesn't stop at application deployment. It includes GitOps, blue green deployments, auto scaling, security policies, observability, disaster recovery, secrets management, and even load testing. So, which closely reflects how modern SaaS companies operate in production. So this is a fantastic example of what dedicated hands-on learning can achieve, and I hope it inspires others in our community to build their own end-to-end cloud native projects. So now let's take a look at what he has actually built. Thank you.
So hi, I'm Suraj. This is a ticketing platform that I built end to end on AWS EKS. So in this we have four services actually. So four services written in Node.js like event APIs, admin API, booking workers, dashboard API. So these are the four services I built. So, but the application is really simple. The real thing I wanted to show was like uh, how everything is built around it, like containerizing it properly, the Terraform infrastructure, the CI/CD pipeline, the GitOps with ArgoCD, and how I enforce the security and observability, and of course the progressive delivery through the canary deployments as well as the blue-green deployment. So I built this over 8 phases as you 8 phases. So phase by phase I will show you. So the thing, let me show you the code. So yeah. So there is this events API. So events API handles browsing and seat selection. So it uses Redis seat lock set 10x for distributed seat locking. So two users can't never lock the same seat. So at like it's similar to Terraform locking, but in the like real time application we use like in the ticket booking app or anything, we use this locking system so that two simultaneously users don't get it. And the code is I took from the internet because like I that was not my aim. So the code I took from the internet, but rest of I did it myself. So yeah. So in this event API, I told right now that this is the booking worker. So what happens is event API, when you book a seat, event API, you can either query the, like you can check the number of seats and events, all those things. But what API will do when you book a seat, it will directly give success. It will directly give success and push the job. There would be a like queue, a Node.js queue. So Redis queue. So it will push the jobs to the Redis queue. So Redis queue, in this we are using AWS ElastiCache. So yeah. So this is the booking workers code. Yeah, all those code it's there. So booking worker will process the booking jobs that event API pushes asynchronously, and then it will store the QR code in a S3 bucket. So and also you will get the email confirmation, but email confirmation I have not updated it. So yeah. And then admin API is just event management with authentication. You can authenticate, you can like create a new event, all those things. Then dashboard is just React front end. It's served by Nginx. Just a minute, yeah. It's stored by Nginx, which also acts as like I also have used it as reverse proxy to the two backend APIs. even though I have ingress, but yeah, that both thing I have done. So let me show you little bit on the events API. So all those health checks, health probes, so that I can like use it in Kubernetes liveness, all those things. So all every even admin, everything has that health check added in the code, so that Kubernetes can hit that endpoint and check for the health. So yeah. So next stage is Dockerization. So before anything, it runs on the Kubernetes. It's like we know that every service has to be containerized properly, and I have used it. Let me show you. Yeah, and I have used multi-stage builds for reducing the image size, so the final stage is starts from like this one minimal base image. It starts, and only like all of this packages npm install, we know that's a huge thing. So we only copy the packages dependencies needed, all those things needed for only the production environment. So this leads to smaller image size, so it's easier to pull and push into ECR. So big images, like if they go one like GBs, like lot of GBs, or even some 600 MB, all those things, they are not that desirable or feasible. Okay, so I have done this Docker file for each. So same thing. Yeah, and also I am adding a health check, like because before running in Kubernetes, we will run locally it in Docker environment. So I will show you. So this is the booking workers. This is the dashboard thing. Dashboard is little bit different because the artifact is static files that nginx needs to serve it, because like unlike development environment, we don't have a running node services. So we use different in one we will build our node project, that code we will build the code, and in another one we will uh, we will serve it through the nginx. Okay, and we are running using this unprivileged thing, because typically nginx runs as a root thing. So most of the packages, image packages, have root uh, have root stuff. So they run as the processes run as root user. So but since it's not a good security practice, plus I will tell you later that how I have added that Kyverno policies to like may to for the strict security standards. So I think that's why even the port is 8080. So we are not running in it in 80 as in the container. So that's why we are using this. So let me show you my, this is the tickets. Yeah, this is my application. So you can go there, you can book it, anything you can book it, like actually it's booked actually. You can book it. So let me show you now the Terraform infrastructure. Yeah, before even writing a single resource, I have set up a remote state. So remote state is an S3 bucket for the state file, and we have used the Dynamo DB table for locking. Okay, so two engineers can never corrupt the state by running apply at the same time. So yeah, so this is for that. This bucket is stored. Bucket I have already created through the AWS commands, and yeah, and for I'm using Dynamo DB for locking the entry. So if a user tries to modify the same thing at the locked thing, then it will throw an error, and it will also give you the message. telling you who did it, and what's the ID, so that the other user can wait for the lock to end, and then he can he can use the apply command, and then create the resources, create or update the resources. So these are my modules. Yeah, this is the VPC module. This is a standard 3 tier like 10.0.0, that's 16 model that would give me 65,536 IPs, because every EKC pod will get its own IP. So VPC IP, that external IP, not that Kubernetes IP. So 3 private subnets I am using. You can check it. Yeah, 3 private subnets and three public subnets, each available in 3 availability zones. And I am NAT gateway I am creating. It gives the private subnet outbound internet, so that they can pull images or use internet for any updates, system updates, etc. And then you add a root table. For public root table, and then you add a private root table and attach it to the NAT gateway. This was for Kyverno pods. So this thing, three resources are little bit overkill, I think. Should not have added it, but yeah, I was just experimenting. So yeah, these are the outputs. This is the outputs it's going to output. And then we have the EKS module. So EKS nodes live only in private subnets on T3 large instances. So yeah, I am creating the cluster, and then I created the node group. So this is for the autoscaler to work, the scaling configuration. So, and that here you have seen it explicitly depends on the VPC CNI, because pods can't get IP address until that VPC CNI is ready. So first VPC CNI should be ready, and then I would be adding the resource would be created. Otherwise, it may create some clash, because node group first would be created first only, and then those VPC CNI would be created later, causing some issues. And these are core DNS. Core DNS is like needed for pods in the cluster to like communicate and identify each other by names. Kube proxy is needed for networking rules, that like we in Linux we have kind of that IP tables rule. We add that firewall, all those networking things. And this is the VPC CNI. It will give the pods those IP address, like not the Kubernetes one. So yeah, those kind of IP address. Okay, so now next I will go to the IAM module. So that's very important module. So yeah, this is open for any GitHub if it needs to communicate with GitHub. It needs to communicate with AWS. Then we create this IAM provider, OpenID OIDC provider. So OIDC will what happens is OIDC will verify whether OIDC and AWS OIDC is a provider that will verify the token given by the GitHub. So that thing we are doing. So even this is OIDC for EKS thing. So using these OIDC, it will verify whether that whatever person or entity mostly that's requesting access to the AWS, it's coming from that repo only, and it just wants and what it wants to access. So that's what. So the thing is, the aim is to have no static credentials. Okay. So each there is a trust policy in each role. You can see that. Yeah. So each role has a trust policy clearly mentioning what it wants and what where it is coming from. So then you attach the policies, like attach the role policy, like what user is allowed to do. So permission, these are called the permission policy. Because the thing is, you can't directly use like even EKS, they have to take create a cluster. They have to get that uh, yeah, a role to use the AWS services outside or inside. The outside also require, outside services also require it, inside also you require it. So these are the roles regarding the EKS. And this is for GitHub Actions, because CI/CD CI/CD pipeline, when it runs, it needs it to access it, it needs a role. So otherwise it would fail. So that's why. So after these conditions are met, it will assume this role. And these all are IAM roles for the service accounts. So if the Kubernetes so the thing is, each like Kubernetes service account, we have like created uh, uh, roles for them, IRSA, IAM roles for service account. So we have created it that for them. And because we every service account, like, yeah, this is for secret, external secret, because when so external secret service account need to talk to AWS secret manager, it needs a role. Without role it can't talk to external so AWS secret manager. So these are the policy what it can do. Like it can get a secret value, it can describe the secrets, it can list the secrets. Okay. And this is for ALB application load balancer. For a application load balancer also, it needs like to access the cluster, all those things it needs, like to all those things. Even application load balancer needs a role. This is for cluster autoscaler. It will come into play when like the load increases and the cluster would scale up. And this is for uh, because even we are using Kyverno policies manifest. So that needs a policy to check to check the to check the versions. Because since we are using Cosign verification, it needs to check the image, whether it has been done correctly or not. Means it that image matches uh, the image it has signed in the ECR. So it needs access for that one also. Sorry, pods. First, it needs to get the access to the pods first. This is the keyword no ECR I have created. This is for the booking workers ID, because this one I am creating a S3 thing. So I need to create as booking workers will that it will generate a QR code to the S3 bucket. So for that I have created those roles. So RDS runs, I think, multi availability zone post JRE SQL. So standby is in second availability zone. So in case one fails, then that second availability zone, it would get second availability zone, it would become the primary database, primary database instance. So DNS endpoint never changes. Its security group only accepts connection. It only accepts connection from the security group of the So this is the security group of RDS. So only those instances that are in the security group of RDS, it would be connected to this. So that means any other pods or like they can't connect to the RDS directly. So that's how I have enforced this security. And this is the secret names. I am storing the secrets in the AWS secret manager. So yeah, you create a node subnet groups, like you will all, of course you will put them in the private subnets. So yeah, here you will mention what instance class. I'm using t3.micro, not a big, but yeah. Elastic cache is more or less same as RDS. How I have done for RDS, similar I have done for electric cache. Like nothing much different. In this only, I am not using any. You are directly connecting through the Redis host. So that I am storing in a secret manager. Okay, now let's go to CI/CD pipeline. So every push to main runs a three job pipeline. Let me show you. First, semantic release reads all the like all first semantic release will release all the commit messages. Like feat will bump the minor version, fix will bump the patch, and a breaking change will be like breaking change will bump the major, like it would go from 1 to 2, version 1 to version 2. So second, here I have, yeah. So here I am using the matrix this setting. So every service will run every service like each every service will run in parallel, built in parallel. Like this is the GitHub matrix strategy. Each gets scanned with drive, and then it's pushed to ECR, then signed with cosign, then signed with Cosign using keyless signing. So no private key stored anywhere. So the signing identity is tied to that workflow running on the main branch. And then you will update the GitOps repo. So I have written this in app of apps pattern. One root app will watch the entire app directory in the GitOps. It will watch the entire watch the apps directly in the GitOps repo. So it will just check into that app thing, and it will see. It will check all the YAML, and it will create a child application for every YAML form. So all those you can see all those YAML I have already defined it. So I will tell you about all of them. So this is for ALB. So I am creating AWS load balance controller. So whenever it sees the ingress, it will create the application load balancer. So I have this is a pod. So I have installed it through the Helm, and I am of course using that role that I showed you in my Terraform thing. This is for Argo rollouts, because I have used many type of deployment strategy like Canary, and Canary I did it first. Later I did blue green deployment. So this is for this, and this is for cluster autoscaler. So this is another like controller kind of thing that I am installing through the Helm. Okay, and this is the ESO, external secret operator. So the thing is, since the secrets are stored in AWS Secret Manager, so the what ESO will do is it will check from the it will it's a pod running, so it will check it will check the cluster secret store from where it needs to pull. So and it will pull the secret from AWS Secret Manager and create its own Kubernetes secret. So in this part we are not creating the Kubernetes secret. So this is the job of this. This is for prerequisite, anything it needs to apply, and we have used this wave pattern. So first you create first this will happen, second it will secrets will happen, Third, it will third it that cluster autoscaler will happen. All those things we are doing. This is for Valero disaster recovery. This is for that tab. So these are that all config maps, deployments I have written external. This is for each I have written this external secret. So you mention here like what you want. That ESO will check this and it will see what it wants and it will pull the same thing from secret manager. So ESO will first check this external secret. So you need to mention all those things. One thing you notice, we have not used service for booking workers because it will just do the work. It will just take the job from the node that Redis queue, and it will just update the database and the Redis RDS instance and the Redis. So it need not you don't need secrets for, service for it. Sorry. So this is the events API. That config map, same thing. And for I need to forgo I need to forget you to tell this HPA. So for booking workers and events API, I have used HPA because these are under huge load. Because whenever users start booking lot of users start booking lot of seats, like it's like some flash sale season or some event, some mega event happening. Then in those case, these two services will be under huge load. So I need to put HPA to scale up the load when the load increases. This is for the ingress, as we know, like it will route the services to the different like in the it will route the services it will route it to different services. Like if it's API event, it will go to the events API service. If it has to go to admin thing, you have it will go to the admin API service. If it's the even for authentication, that's for admin thing, it will go there. And if it's just normal, then it would be front end, that dashboard like which the users will view it. So it would be like that. And then jobs, this is for migration. If like tomorrow, if users add new columns or they change the schema, then the DB migration should always run. And these are service monitors because there is I have installed that cube Prometheus like operator that has everything, that Grafana, all those things, Prometheus operator, all those things stored as a pods. So what if it needs to scrape the application metrics, then you need to define a service monitor that will it will look into the admin API pods and it will scrape the metrics, so that will help us to build Prometheus roles and all those Grafana dashboards. So this is for events API, this is for admin API service monitor, and this is the this is empty. This was generated automatically. This is the ticket ops from where we have defined the SLOs, what the high error rate, and we have done the Slack integration. So high heap memory, yeah, all those things. So these are the namespaces I have created, ticket ops. This is the external secrets for the external secret namespace, and this is the external secret service account that I showed you. I have annotated it with so that it can use that AWS role. So you annotate it in the you annotate the row it with the role ARN. So these are the network API, network policies. Like every pod should not be able to talk to every pod. So you restrict it through the network policy. The first step is to deny all. Like no pod should be able to talk to any other pod. Later you add specific roles. Like for admin only the dashboard or app needs to talk to get the admin login thing screen, all those stuff. So it will that ingress app that dashboard pod will can connect to admin pod and then do all those things. And these ports are for like this is for a port is for it needs to connect to admin needs to connect to RDS instance, and it needs 53 is for DNS, so you of course you need it. Then you create this booking worker network policy. So booking worker, no ingress is needed, but it needs to talk to Redis. It needs to talk to DB, that RDS instance at 543, and of course 53. So dashboard is like dashboard needs to need not talk to anything. Need not like someone need not connect to dashboard. That admin like dashboard needs to connect to admin API for the admin things, and it needs to connect to events API for the event thing, like getting the event list of events and the ability to make a post call, all those things. So this is events. Yeah, this there is also a PG bouncer pod also. So PG bouncer should be able to PG bouncer should be able to talk to the RDS instance, so there is egress for it, and all those events API, admin API needs to talk to PG bouncer, because PG bouncer will sit in between the RDS, sit in between the RDS instance, because like in when lot of users come, then you can't have that RDS instance will crash under the so many connections open to it. So PG bouncer solves that problem. And this is the seat lock. So this is for seat lock. I think these are the jobs. I think seat lock will run every minute and check the lock has expired or not. And this is the PG bouncer. Yeah, what I told you, PG bouncer will PG bouncer will sit between that and sit, and it has its own pool of connection that it will give to the other pods. So the other pods will not directly connect to RDS. So that makes easier for RDS. Otherwise, if lot of users like they directly connect to RDS, then that lot of connections can spike and crash the RDS. So all those this is the config map. These are the policies, Kyverno policies I have added. So, and no pod should have latest tag. It should have particular version. So since I am signing it with the semantic version, so every pod will have the what you say, every pod will have the tag. Okay, so even so this will check if it has a latest tag. It will first I used the audit actually. Audit means it will not apply to the existing pod, but later when you fix everything you can add the enforce, then it will reject the pods, so it will not allow the pods to run. This is for root containers. So as we know, containers should not be run as root, so it's a big security issue. Then it should have a label. So every pod should have a app that labels, like this thing we have version also it needs to have anything. And resource limit, every pod, like for some pods I think we don't mention the resource limit also, so this will fail those pods, because every pod needs to have a resource limit, and otherwise it will like they would consume lot of memory, and the other pods would be killed by OOM, killed by the that Kubernetes. And this is for verifying signature. So any malicious user can verify the signature with fake thing. So it what it does is it stores whatever you have done. Cosign verification has done, it stores it in Recore 6 store. So it will this will check that whether the this will check whether the signature that this image has matches with the records sign store. So that has a particular time, all those things, timestamp, all those things. So it will verify it. So that's how it will happen. So it will check it. So record is like a public, like a legitimate public database of all those image digests. SHA 256 you commit, you say, right? All those things. And then this is a role, RBAC roles. So all for each set of services, I have created a role and a role, all those roles, and then role binding. I have binded it to the roles. So every service account has a role. So all those things I have done. We are not using the default service account. So this is the secret store, because AWS that ESO needs to know what it needs to check from the cluster secret store, which is a CRD thing. So it needs to check it from the cluster secret store, like what's happening, and what it needs to pull, what thing it needs to pull, what service it is, all those things, and what service account it is, all those things. So all those stuff are mentioned. So now let me show you that these are my Grafana dashboards I built. That high error request rate, like some how many request rate it is happening. This will check, and this is for the error rate. Okay, so it should be how much it should this is the error rate. Like it should not cross below a particular threshold. Like for in my case, I think it's one like 0.1%. And then this is the latency. It should be, and this is the booking rate. This is the event loop lag. So how much event that event loop would in the Node.js, it will execute the service, execute the jobs, right? So it will check how much lag it will take. So all those dashboard I built it. After that, what I am thinking is I will show you. I will just load test my application and uh, show you the results. So yeah, actually I even took this, but this was during I was getting lot of errors. Now it has been fixed. It I will show you. There were some I was using some wrong endpoint, and there was no caching for the booking event. So all those I resolved, and I will show you that. I will show you with 200 users, because it gets quite 200 will get is enough. 500 puts a little bit of load in it. So yeah, let me show you. So this will gradually start increase, like it will simulate like real time thing, like real time user browsing the events, booking the seats, all those things. So gradually it will ramp up. Like first it will start from 0 to 50, and then from 50 to 200. Gradually it will increase, and all these are the SLI sectors. So rate should be less than 5%, and this latency it's 4,000, because I added 4,000 because that it takes a little bit of time, because user will push to S3 that QR image code, so that will take time. That's why it's little bit high. So yeah, so because otherwise it would fail the SLOs. So that's why I added. But yeah, you can give me your opinions, and like any inputs, whatever gaps you found in this. So yeah, let me run this. Till then, I just a minute. I will show you my all services. These are my nodes. These are my pods. This is the HPA. Also see this. This is my application list. Everything is synced except this one, this thing. But this is like a problem with Argo Helm. This is not nothing you have to done from my. Let me sync again. See, cluster autoscaler also worked. It also scaled up. See this thing. So now there are total of four nodes. Previously it was three. It was three nodes. So see, cluster autoscaler is also coming into action. I think I should not have created the admin API HPA because I just created it. I need not created it because there is no point, because it will not be used by the external users and it would not be subject to lot of loads. So yeah. Also, after this, I will simulate the blue-green deployment ID. Previously, I did it through the canary, like you set the weights. You first move to 20, then 40, 60, 80, 100, those kind of weights. And then uh, that also worked. And then I also implemented the blue-green deployment also. See, the error rate is less than 1.7. This is, I think, this is some issue because 409, it gets 40, it throws it as error whenever it's 40, like error code is 403 also. So when the seats are booked and it, so when seats are booked, then when the user tries to book the already booked seat, then you get a 409 error. So I think it's calculating those errors also. But as you can see, the error rate is 1.70. It's quite lower than 5%. So yeah, and these would be small timeout errors. It could be. I need to check it, but yeah. Okay, now let me do this. So I'll show you how it works. First, yeah. Now it will work. It will run. This application will run. Yeah, you can see this. When the load ran, then you can see the all those spikes we got. Yeah, as you can see, it succeeded. Now let me again refresh. I will pull the requests. Let me merge it. So when GitOps will merge, then that ArgoCD will detect it and poll it. It will poll the Git cluster and it will check. So it has overwritten all those things. Now I think it should be triggered. Yeah, you can see now. Then now this is in preview. So I have created this preview API service because this is for that testing that version we want to deploy it to the deploy it to the new stable version. Let me show you. This is the normal service that works. This is the preview service that I have created. So in typical case, what it will happen is, so in typical case, preview, we would in the normal real time thing, we will first check, we will go to this preview service and test this service for like in a separate environment, and then only we will switch the rollout to this preview one. That is the blue colored one, that's green deployment. So for now it's like I have not made any change, any like different change. So I will just roll out just promote it to the new preview version. So that would be the current, that would become the stable version. Okay, so now I will show you that. Yeah, I think now you can see this. Yeah, now you can see that this one became the stable active version. See, previously it was not. Previously it was changed and now it became the stable active version. Yeah, see this, in previously it was like this. Now it's like this. So yeah, this okay. I just wanted to add one thing. Valero. I wanted to tell you about Valero also. So these are Valero stuff I wrote. For Valero, I created the buckets to store the backups, and then the role for the Valeros to access the Valero thing. So Valero, I created it backs up every Kubernetes resource in the ticket or OPS namespace to S3. Plus, it would also EBS. It also take EBS snapshot if any PVCs are there, persistent volume are there. So a manual backup can create a 574 resources in 3 seconds. So there is so if the namespace were ever deleted or corrupted, Valero restore uh, will bring back everything in minutes. So that's the advantage. But I think it's more of an overkill since we already have the GitOps, like the state of the cluster. Only thing is you will have the state of the rollouts, all those things stored. Otherwise, I think GitOps is better. But yeah, so you can using that restore create all those things, you can just commands there are, so you can just do that backup create all those things. So this ends my demo. Anything you note, any gaps or any stuff you can mention, you are welcome to mention it. So I will thank you, I will stop it now.
And before I go, I would like to talk about my YouTube membership program where I have a lot of premium videos available. As you can see right now, I'm talking about a production Docker file. So this is a sample Docker file from a production environment, which I'm covering here, and I'm explaining each and every instruction that is there in this Docker file. Apart from that, I also have videos on some of the most important site reliability engineering terms that are often asked in the interview. How do you explain that? I have video on SRE golden signals, which is very critical when you're actually working and you're configuring some dashboards for a particular application. So you would need SRE golden signals. And then I have a hands-on project on SLI, SLO, SLA. So I start with the theory, like how do you explain these terms and how do you explain an end-to-end project that you've done on SLI, SLO, SLA. So that I've covered here. Here you can see I'm using a Java Spring Boot application, which is being monitored using Prometheus and Grafana tools. And the application is deployed into AWS EKS clusters. Apart from that, I also have video on distributed tracing with Grafana Tempo, and I also have one video on how do you use open telemetry for metrics collection for a Java Spring Boot application in Prometheus and Grafana. So it's again, all these videos are hands-on, which means that I'm going to share the document, the end-to-end document that I'm following here, and how do you configure all these things in real. So all that I'm trying to cover here. Apart from that, I also have video on logs aggregation using Grafana Loki tool for Java Spring Boot application. So how do you aggregate logs from multiple applications into Grafana Loki? So that I am covering here. Then in production, we don't use the standard Prometheus to collect our data. We use an enterprise solution which is called Mimir. So the difference between Prometheus and Mimir I've covered in this video. I also have a shell scripting crash course with production scenarios where I'm going to talk about the type of questions that are asked in the interview. Apart from that, all the fundamentals of shell scripting that you should learn for the interview. Then I have other videos as well. As I mentioned, I have multiple videos on Prometheus and Grafana based Java Spring Boot application monitoring in production, how it is done. So these are the videos. Apart from that, I also have Terraform, I have Kubernetes, and I have AWS, Linux, and you can see some of the videos in my YouTube membership program are actually recordings from my real live batches that I've run for SI trainings. A lot of people have got the job as well. So I have these recordings as it is, and in each of these videos I'm talking about how it's going to look like when you're actually working in real as an SRE. So I'm talking about all that. Yeah, so these are the things that I have on my channel, so you can take a look at it. If you find it useful, you can go for the membership as well. It's going to immensely help you in your interviews. All right, so that's all I wanted to cover in this video. I hope this video was useful to you. If it was, please hit the like button. Please share this with others. Please do subscribe to my channel and keep watching my channel. All right, guys, that's all for this one, and I'm going to see you in the next one. Bye for now.